Okay, everybody. This one won't take very long. This one's actually really light and really sweet. Because of all the work you've already put into it, graphing logs is actually pretty easy, but there's some issues I want to tell you about. So, to review, f of x is equal to a of x, and the function g of x is equal to log a of x are inverses of each other, just like we explained when we were talking about inverses. Generally, a to the log a of x should give you back x, and g of f of x, that means log a of a to the x gives you back x. Okay? They're inverses. And that's a huge deal. In addition to that, we talked about logarithm properties, right? So you know that log base a of x, it has a domain. X has to be bigger than 0. And it has a root when x is equal to 1. Okay. You know those are true. And also, y is equal to 1 when x is equal to a. Same number as the base. Okay? We talked about these as generic properties of how logarithms work. Okay? Now, in addition to that, we had exponential graphs. Exponential graphs were shaped like this. Okay? What were the properties? There was a horizontal asymptote. It gets bigger over here. And there were two more fantastic properties. One is that it has, all right, so this is a function of a to the x. It has, at x is equal to 0, it crosses the axis at, 0, y is equal to 1. And the second thing is that when x is equal to 1, y is equal to a. Okay. These are all basic properties that we learned in past videos. None of this should be new. But the thing is, if we want to talk about graphing logs, we can do it in a really easy way, combining all of these things together. Mush them up in a great big logic salad. It's going to be super fun. Okay, so, like I said, they're inverses. So let's start with a graph here. Careful as we work here. All right, so 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. All right, so that's x, that's y. So let's plot the function y is equal to 2 to the power x. Plot it in blue. You know that it goes through this point, and then it goes through this point, and so it has this shape. There's a horizontal asymptote, goes through that point, and then that point, and then, you know, that doubling, characteristic doubling feature. Cool. Okay. I want to draw the inverse of this. What's the easiest way to draw the inverse? It is to draw the line y is equal to x. Click. Good. And draw its reflection in it. Okay? So first, the reflection of this point, that's 1 over horizontally, is going to be this point. 1 over vertically, so it's going to go through there. The reflection of this point here, 1 over horizontally is 1 over vertically. So it's going to go through that point there. If I want to, I can do the next one. So the next point here should be at 2 above there. So it's going to be 1, 2 over here. Okay. So then what? What about this behavior over here? We know that the graph is going to be shaped kind of like that to mirror it. As this one slopes upwards, this one gets more and more sideways. It doesn't get quite sideways. It doesn't have an asymptote. It just gets shallower. Okay? And as this one approaches, well, what's this axis? This axis, what's its mirror image in the mirror? The mirror image of these points are these points. Okay? So the backwards x-axis is its mirror image is the backwards y-axis. And so as this graph approaches the backward x-axis like that, this line's going to approach the backwards y-axis. It's going to have a vertical asymptote. And there you have it. Just like we said, all of the properties of logarithms. Let's go. This guy. Come on down, friend. All of the properties of logarithms can be explained with this graph. Well, not all the properties, but these particular properties of logarithms can be explained with this graph in terms of the thing. So first thing to talk about, well, let's take it easy. Root. Why are the root of all logarithms at x equals 1? It's because we talked about how exponentials all go through when x is equal to 1, exponentials have y is equal to 1. And the mirror image of this y-intercept is going to be the x-intercept, right? So whenever x here is equal to 1, the value of y here is going to be equal to 0. X-intercept. Well, that's interesting. What about the other properties? Next one. Why is it that for any log function, when y is equal to 1, x is equal to a? That's because this characteristic point and this characteristic point are mirror images. That makes sense, right? So whenever x here on our original function is equal to 1, y is equal to the base, and its mirror image here is going to be this point. So whenever x is equal to a, y is going to equal 1. So those are two really fun points. Those are super important when it comes to graphing it. But the most interesting and the most important aspect of graphing a logarithm is this vertical asymptote. Because what happens is our logarithm is only going to be defined for values of x that are positive. And the reason is, it has to do with this exponential. We argued that this exponential, when we're graphing this exponential, it's always positive. And the reason it's always positive is because we're always doubling or halving a positive number, right? Well, because of it, the domain of our original blue function, this guy, its range is y bigger than 0, right? And when I reflect it, make its inverse, that means that the range, when you make your inverse function, the domain and range are going to switch order, right? So the range, or the domain of this function is only going to be x bigger than 0. It's because of these shapes, right? Okay, so this is really fun. It turns out that the shape of the logarithm is entirely defined by this shape. It's the same shape but tilted sideways. Instead of getting really big really fast, it gets big slower and slower and slower. Instead of a horizontal asymptote, this one has a vertical asymptote. Okay. So let's talk generally about how to plot a logarithm. Logarithms generally have this shape. Ooh. And by plot, I mean sketch. Sketch a log. Okay, so you want to sketch a log. What you do here is you draw a circle, and you draw another circle here. And then down here, you draw the bottom part of a circle. Then you connect these together and draw a line up and draw a line down. And then you draw a line sideways like this, sideways like this, and you draw some it's a log. No, that's not the type of log we're talking about. We're talking about logarithms. Logarithms always have the following shape. Variations thereon. We'll talk about the variations in a second. But just, they essentially have the following shape. Looks like this. Okay? There is a vertical asymptote. So this is y is equal to log base a of x. The vertical asymptote is going to be where the input to the log function is equal to 0. Okay? There's going to be a root. The root of the log function is when the input is equal to 1. And then there's going to be a point out here when x is equal to a, y will equal 1. Okay? So, knowing those three things, we can always sketch the graph of the log. I just want you to remember the shape, though. It always has this vertical asymptote. It gets steeper and steeper and steeper, and there's no end. All the way down. So, vertical asymptote. There's going to be something 1s in asymptote. There's vertical asymptote. There's a root when the input is equal to 1. And y is equal to 1 when the input matches the base. All right? So we can use this information. Essentially, we know the shape, and so we can sketch what these log functions look like. So let's start here. The issue here is sketching, right? You don't have to draw a super nice line, but you want to be able to sketch it. Let's try a simple one. Y is equal to log 4 of x. The issue here is figure out where the asymptote is, figure out where the root is, and figure out where the input is equal to the base. So the asymptote is going to be where the input of the function is x here, is equal to 0. So the asymptote here is going to be x equals 0. So what you want to do there is draw a vertical line at x equals 0. I'm going to draw one right now. Doot, 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 doot. Okay, at x equals 0. Next, the root. The root, y is equal to 0, is going to be where the input is equal to 1. The input's x here. So at x is equal to 1, the input is going to be 0. You put a little x there. Finally, when the input is equal to 4, the output's going to be 1. So when's the input? The input is x here. It's 4. Y is equal to 1. You put an x there. 2, 3, 4, 1. All right. And this tells you the shape. You know that the shape is going to be like that, or it's going to be like that. Which one is it going to be? Well, you know that it has to connect these two, so it's probably going to cross the x. Logarithms only cross the x-axis in one place, so it's got to be like that. And there's your sketch. It's not a good sketch, but it's an okay sketch, and that's all we need for right now. The purpose of sketching is, it's not technical graphing. The purpose of sketching in mathematics is often to figure out the attributes of a function. Does it cross 0 somewhere? Where around does it cross 0? That kind of stuff. So even if it's a lousy sketch, it'll still tell you important information. How about this one? Log 1/2 x minus 2. And before you say anything, oh, look at that, that's not a whole number. It's true. But logarithms are inverses to exponentials, and you can definitely have an exponential function that looks like that, right? Or maybe if you wrote it like this. Yeah? So, as a result, you can have a logarithm with the base negative 1, 2. Isn't that bonkers? Okay, so what does this thing look like? To answer this question, we need to look at the asymptote. We need to see where y is equal to 0 when the input is equal to 1, and y is equal to 1 when the input is equal to 1/2. Let's sketch what this looks like. Maybe I'll move this one over a little bit. There you go. Okay. So, where's the asymptote? The asymptote is when the input is equal to 0. The input of the function is this expression. When that expression is 0, it's equal to 0 when x is equal to 2. So I'm going to draw a vertical line at x is equal to 2. Okay? Next point. Y is equal to 0, so that's a root when the input is equal to 1. X minus 2 is the input. Let's set that equal to 1. That's x is equal to 3. So at x is equal to 3, the thing has a root. Y is equal to 1 when the input is 1/2. Oh, weird. X minus 2 is equal to 1/2. So that's x is equal to 2.5. So that's right there. 2.5. Y is equal to 1. There. Like I said, the logarithm is only going to cross the x-axis in one place, that place. So the question here is, which way is the asymptote? Does the asymptote go like that, or does the asymptote go like that? Well, if it crosses the x-axis at this location, then it means that it's already on this side, so it must go up like that. Let me draw that a little bit nicer. So you follow the asymptote down, you go through this point, and then you curve down that way. That's what the inverse function looks like. And you know what? I mentioned that this expression is the inverse of a trig expression, maybe 1/2 to the x, something like that. If I drew 1/2 to the x, this particular upside down asymptote might make a little bit more sense to you. All right, let's try another one. Y is equal to log 3 4 minus x. Again, only 3 things I need to know. Asymptote. I need to know y is equal to 0 when the input is equal to 1, and y is equal to 1 when the input is equal to, in this case, 3. So what's the input? The input here is 4 minus x. The asymptote is when x is equal to 0. So that's x is equal to 4 is where the asymptote is. 1, 2, 3, 4. So you sketch a vertical line here. I don't know which side of the asymptote I'm coming down on or what the deal here is. Next part. Y is equal to 0 when the input is equal to 1. So here's the input. It's equal to 1 when x is equal to 3. So that's here. That's where the root is. And y is equal to 1 when the input is equal to 3. 4 minus x is equal to 3. So that's x is equal to 1. Y is equal to 1. All right. So now I want to draw something with a vertical asymptote. I guess this shape and this shape are out of the question. But, you know, I can draw 2 other shapes that are kind of like that. It could be like that, maybe. Or this is the vertical asymptote. Or maybe it's like this. That's a vertical asymptote. So which do you think it is? Well, it can only cross the x-axis in one place. It's right here. So my guess is that it comes up like this. It goes through that point. There you have it. A nice graph of a log. Okay, so that's it for graphing logs. You just have to ask yourself these 3 things, and then you're good to go. Remember that asymptote. Super, super important. Talk to you later.